Okay, we have 9.4 inequalities in the absolute value. So let's start with where we kind of left off last chapter, or last section. We're looking at the absolute value of x. And remember that we were saying that we want to rewrite that as x equals 3 and x equals negative 3. So this answer has two answers or solutions. And that would be negative 3 and 3. So let's do one more from 9.3. X plus 2, I'm sorry, the absolute value of x plus 2 equals 4. So again, if you remember back from 9.3, you're looking at rewriting it as x plus 2 equals 4 and x plus 2 equals negative 4. Because if you remember, I know if I put in here a positive 4, the absolute value of 4 equals 4. If I put a negative 4 in here, the absolute value of negative 4 makes 4. So that's why we do this. Then you're looking at simple solving. Draw your mirror, subtract the 2 from both sides. This gives me the 0, and I'm left with an x on the right equals 4 minus 2, which is 2. On this side, again, make our mirror, sorry about that. Subtract the 2 from both sides. That gives me a 0. Bring down my x. On this side, I get a negative 6. So this one has two solutions also. One is 2 and the other one is negative 6. So that's what we talked about in the last chapter. Now what I want to look at now is with an inequality. So with an inequality, if we're looking at the absolute value of x as being less than 3. All right, so it's going to be very similar to what we did on the problems on the last section. We're going to rewrite. Let me move that over a little bit. Rewrite the problem without the absolute value. So first without the absolute value. And everything's the same. So everything stays the same. That's step 1. Step 2, you're going to rewrite the problem without the absolute value. So everything stays the same so far, absolute value. Then you're going to flip the inequality. Remember, an inequality just means it's not equal. So that's your less than and your greater than sign. And change the sign. So you're going to make it opposite. So for example, we rewrote it without the absolute value. We're going to rewrite it again without the absolute value, except for we're going to flip the inequality. Was less than, now it's greater than. And we're going to change the sign to a negative 3. So for this problem, we do have two solutions. Let's go ahead and graph it. Here's my 0, 1, 2, 3, positive 3, 1, 2, 3, negative 3. And remember that it's an open circle because they do not have an equal sign. Now what we need to know is, are we talking about a conjunction and we're coloring in between or not? And so we need to look. I'm looking for an x that's less than 3. Well, an x less than 3, I would say 2, 1. So I'm coming down this way. So less than 3 would be this way. Then x is greater than negative 3. So we're starting at negative 3 and going bigger. So we're going in that direction. Bigger than negative 3, 0 is bigger than negative 3. So it looks like I'm coloring in between right here. Let's take a number and do a check. So let's take 1. Okay, so we're going to take the absolute value of x is less than 3. We're going to change x to 1. And the absolute value of 1 is 1, and that is less than 3. So we know that's going to work. Okay, so now we're looking at the absolute value of 3x is less than 15. So if we go back to our steps, we're going to rewrite it without the absolute value completely. We're going to rewrite it without the absolute value, flip the inequality, and change the sign. So it's a positive 15. We make it a negative 15. So again, we know in here, think of it kind of like the equal sign. If this was last section where they were actually an equal sign, I would be saying, okay, in order to get 15 as my answer, I can put in here a 15 or I can put in here a negative 15. Either way, I'm going to get that answer. So now we're going to solve it. And remember, solving inequalities, you've already done that. So you pretend and you think of it like it's an equal sign. So I can even draw my mirror. 3 times x, so I'm going to do the opposite operation, divide by 3. X is less than 5. Over here, absolute value gone now, so I'm going to go ahead and solve. Here, divide by your 3. X is greater than negative 5. So now I have my two solutions. I take my number line out. So here's negative 5, here's 5. They're both just the inequality. There's no equal sign involved. So they're both open, if you remember that. And now let's see which direction we're going to be coloring. So an x is greater than negative 5. Well, 1 is greater than negative 5, and here's my negative 5. 1 is way over here, so I know I'm coloring that direction. Take this one. X is less than 5. I know I'm looking there, so I'm looking good. And I'm going to color in between the two. Let's do a quick check again. I'm going to use 2 this time. Take this. The absolute value of 3x is less than 15. The absolute value of 3 times 2, because I said I'm going to check the 2. It's in the answer here in the solutions. And 3 times 2 is 6. The absolute value of 6 is less than 15. So I know I'm good to go. If I needed to, I could check it again with a negative number and see if it worked out the same. Okay, so let's try this problem, which is the absolute value of x plus 5 is less than or equal to 9. So again, we go back to our steps. We rewrite without the absolute value. Boom. We rewrite without the absolute value, switch the inequality, change to the opposite or the negative 9. Now I'm going to solve them. Again, think of this like an equal sign, so we're going to make it a mirror. It's adding 5, so subtract the 5 from both sides. This gives me a 0, and I'm left with x is less than or equal to 4. Again, getting the x by itself, subtract the 5 from both sides. This gives me my 0, and I'm left with x is greater than or equal to negative 14. They're both negative. I add them together. When I go ahead to make my graph, all right, so x is less than 4, so that means I'm going 1, 2, 3, 4 over here. And then negative 14, which is going to kind of fit sort of in here. 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to have to extend my line out. 9, 10, 11, 12. 13, 14. So there's negative 14. So I know that x is less than or equal to 4. So that means we're looking at a closed circle because of the equal sign. Negative 14 is also a closed circle. And then now we got to decide if we're coloring inside or on the outside. X is less than 4. So you start thinking about what's less than 4. 1, 2, 0. Those are this way. Looks good in this case that it's going to be in between. So x is greater than 14, negative 14. 0 is greater than negative 14, and that's that way. So I'm going to go ahead and color inside between the two dots. Okay. Sorry that there we go. That's better. All right. Let's try another equation. This one we're looking at the absolute value of 3x minus 4 is less than or equal to 2. So again, rewrite without the absolute value. Everything else stays the same. Rewrite without the absolute value. Switch the inequality and change this to a negative number. Because again, we're looking at this and we're saying, okay, whatever's inside here has to be less than or equal to a positive 2 when I take the absolute value. So it could be negative 2 or it could be positive 2 inside here. We don't know because it's the absolute value. Again, solving opposite operations. We're looking at multiplying times the 3 and subtracting the 4. And remember, we look at addition and subtraction first. -4, we're going to add the 4 to both sides. This gives me my 0, and I'm left with 3x is less than or equal to 6. Divide by the 3. X is less than or equal to 2. Okay, again, I'm going to add the 4 to both sides. And you're going to follow the same steps as before. That gives me a 0, and I'm left with 3x is greater than or equal to, and it looks like a positive 2. -2 and a positive 4 makes a positive 2. Divide by 3. X is greater than or equal to 2/3. So again, even though it's a fraction, it's not a big deal. Go ahead and graph that. I'm going to move that 0 over here. I'm going to make the 2 here. And then 2/3 would be less than 1. And I'm going to kind of eyeball it. Looks like I think 2/3 are going to go right about there. They're both equal, so that means it's a closed circle. Here and here. Just give myself a little bit more room. X is less than 2. So less than 2 would be this way. X is greater than 2/3, and we're looking at this way. We're going to do one more example right now, except for this time I'm going to use some fractions because I know that we're not comfortable with fractions. So what I need us to do first is to follow the steps. Don't see the fractions and stop and don't know what to do. Start with the steps. Okay? So it's an absolute value. I'm going to rewrite without the absolute value completely. Then my second thing says rewrite without the absolute value, change the inequality, and make it negative. Now, the one thing we don't like is we tend to not like the fractions. And remember that as long as there is an equal sign, or in this case an inequality, you can multiply both sides or add both sides, whatever you want to do to both sides to help you out. I want to get rid of the fractions so that the first thing I can do is solve this problem without freaking out. So the common denominator of 5 and 4. Common denominator of 5 and 4 is 20. So if worse comes to worse, you multiply the two together. That always works. If there's something smaller, obviously it would be better to use. So I'm going to multiply this times 20, this times 20, and this times 20. So here, this is 20 is the same thing as 4 times 5. So if I say 5 divided by 5 is 1 and 20 divided by 5 is 4, I'm looking at 4 times 1x minus, again, 20 divided by 4 is 5. So 4 divided by 4 is 1. 20 divided by 4 is 5. And I get negative 1 times 5. And 1 times 20 is 20. Clean that up a little bit. 4 times that is 4x minus 5 is greater than 20. Much easier problem to tackle. So I don't have to freak out because it's a fraction. Now I can just follow my steps. Got my mirror going on. Adding and subtracting should be your first step. This gives you a 0, and you're left with 4x on this side is greater than 25. Okay, next step is divide both sides by 4. And yes, my final answer is going to be a fraction, but it's okay because I'm done. Again, I'm going to multiply every piece over here by the common denominator, and the common denominator didn't change because the only thing that changed was the inequality and the negative in front of this one. Multiplying here again, 5 divided by 5 is 1, and 20 divided by 5 is 4. So I get 4x on this. Again, we're going to get the 5. 20 divided by 4 is 5 times 1 is 5. If you're really struggling on that, you need to come and see me so we can work on your fractions. But if you can get it to this point, it's less uncomfortable, maybe is the word to use. All right, drawing our line. Okay, again, we're going to follow the same steps. Adding and subtracting comes first. That gives me my 0, and I'm left with 4x on this side. Over here, I get negative 15. Divide both sides by 4. We get x is less than negative 15 fourths. Okay, so now you're going to make that fraction into a mixed number. It makes it much easier to graph. So 4 goes into 25. Well, 4 goes into 24 6 times. So I get 6 and 1/4. So I know that where I put that is 1, 2, 3, 4, 5, 6. and a fourth, which would kind of be right here. It's an open circle, and I'm going to write it as 25 over 4. Again, I'm going to look for that mixed number. 4 goes into 15. Let's see, 3 times. So it's negative 3, because I forgot the negative there. 4 goes in negative 3. So we get with 3 left over. So again, we're going 1, 2, negative 3, and so here's our negative 3 and our negative 4, and 3/4. 1, 2, 3. So it's kind of right there. It's hard to draw sometimes, but it has to be just approximately correct. So here is negative 15/4. They're both open circles because there's no equal sign. X is less than this. If x is less than this, less is to the left. That means that we're looking at numbers on this side. So it's less than negative 3 over 4. Well, negative 5 is less than that, and that would be on this side. It's greater than 25/4. That would mean it's bigger, goes this direction. And we're looking at something like 7 or 8. We're looking at 6 1/4. What's bigger than that? 7, 8, 9, 10. So we're looking at the disjunction at that point. I'm going to do one quick thing, just a reminder as solving with inequalities. Let's look at this one. Negative 4x, and it's less than 12. Okay, so we follow all our steps. We copy without the absolute value. We copy without the absolute value, switch the inequality, and make that negative. And now we're solving. We're going to divide on both sides. It's a negative 4, so I'm going to divide both sides by negative 4. Negative 4 divided by negative 4 is x. Now this is where it comes in. It's a little different. Remember what happens if you multiply or divide by a negative number. What do we have to do when we multiply or divide by a negative number? We need to actually switch this inequality. So if you multiply or divide, not subtract, multiply or divide, you're going to flip the inequality. 12 divided by negative 4 is negative 3. Here again, we're going to divide by the negative 4. That simplifies out. It was a negative 4 that I was dividing by. Flip my inequality, and I get 3. So x has to be greater than negative 3, and x has to be less than less than 3. 0, 1, 2, 3. Open circle, because there's no equal sign. Here's my negative 3. X is greater than negative 3, less than 3. And again, we can go back and check our answer. We can say, okay, there's a 1 in here. Or actually, use your 0. It's in the middle. Let's go ahead and plug it in. The absolute value of negative 4 times 0, is that less than 12? And so 4 times 0, negative 4 times 0 is 0, and the absolute value of 0 is less than 12. And so it does work. Okay, so now I'm going to do a couple more problems with you. If you think you've got it, go ahead and stop the video. Go ahead and start the work and see how it does, how you do tomorrow. If you think you need a couple more problems, let's go ahead and do a couple more together. So we're going to do another one like this. So we're looking at the absolute value of x minus 4 is greater than or equal to 5. So we follow our steps again. Rewrite without the absolute value. Everything stays the same. Rewrite without the absolute value. Switch the inequality. Change to a negative number. Solving an equation at this point, adding, subtracting comes first. It's a negative 4. I'm going to add the 4 to both sides. This is a 0, and I'm left with x is greater than or less, or greater than or equal to a 9. Here's my first part of my answer. Over here, I'm going to add the 4 to both sides, and don't forget you have the mirror. This gives me a 0, and I'm left with x is less than or equal to negative 1. So if I say this is 0, this is my negative 1. 1, 2, 3, 4, 5, 6, 7, 8, 9. Take my sign out there. And this is an equal to sign. So that means I have a closed circle. X has to be greater than 9. x is greater than 9. I'm looking at 10, 11, 12. That's a disjunction, it looks like, possibly. Goes in that direction. X is less than negative 1. Less than negative 1 would go this way, like negative 2, negative 5. So we're looking at that disjunction. Let's try one more. Rewrite without the absolute value. Rewrite without the absolute value. Switch the inequality. Make it negative. Opposite operations, it's adding 4. We always do addition and subtraction first. We're going to subtract 4 from both sides. This equals the 0, and we're left at 2x on this side is greater than or equal to 12. Opposite operation says divide by 2. X is greater than or equal to 6. Over here, opposite operations again, it's a positive 4. Subtract the 4 from both sides. This does give me a 0. I'm left with 2x is less than or equal to negative 20. Divide by 2. X is less than or equal to negative 10. Let's go ahead and graph that. Make sure this time I leave enough room to graph it. So 1, 2, 3, 4, 5, 6 is right there. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So I'll move my line down there. All right, it has an equal sign, so it's a closed circle. And it has an equal sign, so it's a closed circle. X has to be greater than 6. So again, greater than 6 would go this way. And x is less than 10 is this way. Let's check that answer really quick. Let's use something in the middle and see if it actually works. So let's use the 1 and see if it works or not, because it looks like it's not going to work. Let's check it out. 2 times 1 plus 4, absolute value has to be greater than or equal to 16. So 2 times 1 is 2 plus 4. And 2 plus 4 is 6 is greater than, no, it's not greater than 16. So I know that I must be on the right track because nothing in here is looking like it's going to work and 1 did not work.